Today we're going to talk about combination circuits. And in this first video, we're just going to talk about how to find the total or equivalent resistance of a combination circuit. A combination circuit can be a little bit difficult because it's got elements of both series and parallel within the circuit. And so finding the equivalent or total resistance is not as simple as it is with just a series circuit or a parallel circuit. So we're going to start off with the easiest combination circuits we have, and that's one with just 3 resistors in it. So on this one, we've got 2 resistors here in parallel, and that element is in series with this one. So in order to find the total resistance for this one, I need to first collapse or combine this parallel part, and in that equivalent resistance of this section is in series with that one. So since these are in parallel, we find the total resistance by adding the inverses. When we do that, we get this decimal. Now, that's not the total or equivalent resistance of that section. We have to hit the inverse button one more time, and we get a total resistance of 7.5 ohms for just that section. Now, that's in series with the 5 ohm resistor. So, since they're in series, we simply just add the 2 resistances up. So that circuit has a total resistance of 12.5 ohms. For the second circuit that I've drawn here, notice it's a little bit different. As you get to this part, it splits. And we have these 2 are in series with each other, but this element's in parallel with this one. They recombine and go back to the other side of the battery. So on this one, the first thing I want to do is actually combine the series part into one resistance. And in series, we simply add the 2 resistors together. So this has an equivalent resistance of 25 ohms. And that's in parallel with a 12 ohm resistor. So we find the total resistance again by adding up the inverses. We get 0.12 and 3 repeating. But again, we have to take the inverse of that to get the total resistance. We get, 8.11 ohms total resistance for that one. Now we're going to add a 4th resistor and try a couple of those. Okay, now we have combination circuits of 4 resistors. We still have to look at which part we can collapse first in order to eventually get the total or equivalent resistance of each circuit. So on this first one, if I look at it, we've got current coming out of the battery going through this resistor. The wire splits, so that lets me know there's a parallel part. It goes through here, and then comes back together before returning to the battery. And so I know I've got one parallel part and a couple of things in series. Matter of fact, this parallel part is in series with these other 2 sections. So I want to go ahead and find the equivalent resistance of this section first. Since it's in parallel, I go ahead and take 1 over 8 plus 1 over 24. And we get 1.6 repeating. And we get 0.16 repeating. We need to take the inverse of that and we get an equivalent resistance of just 6 ohms. But that's just for this parallel section. But that's in series with these other 2 resistors. And in series, the total resistance is just the sum of all the resistors. So 4 plus 6 plus 10. So that means this circuit has a total resistance of 20 ohms. For this next circuit, notice I didn't draw in the battery. Sometimes you'll see this. Sometimes they'll just give you a segment of the circuit and want to know the equivalent resistance of it without giving you details about the battery. That's okay. That's not going to change the problem at all. Now in this one, we've got a series part here, and then it branches off into a parallel part here. And each one of these are in parallel with each other. So I'm going to go ahead and find, again, the equivalent resistance of this parallel section, and then add it to our single resistor that's in series. So in parallel, we're again adding the inverses. And if we do that, inverse of 20 plus inverse of 5 plus the inverse of 4 gives us 0.5. So if we take the inverse of that, we get a total resistance of this segment, of just the parallel part, of just 2 ohms. So this whole thing is equivalent to just 2 ohms, which makes sense because remember in a parallel circuit, the total resistance is less than the smallest resistor. My smallest resistor was 4, so I know the total resistance of that parallel component has got to be less than 4. But now this whole segment is in series with that one. So to find the equivalent resistance of the entire circuit, I just have to add those 2 together. We get a total resistance of 10 ohms. For the next part, let's add a little bit more difficulty into the circuit, and you find the total resistance, and we'll see how your answer compared to mine. Okay, now we've got 2 new circuits, and on this one we have 4 resistors, on this one we have 5. What I want you to do is try to find the total resistance of each circuit, and we'll compare them to what I get. So, pause the video here, try it on your own, and see what you get. I'll be back in a second. Okay, now that you've tried it, let's take a look at these. So for this top one, I've got where the current comes out splits. Some of that current goes through this line, and some of it goes through here. So I've got a parallel segment. But in this line of this parallel segment, I've got 2 resistors in series with each other. The circuit combines back together, and the current goes through that one and back to the battery. And so I first need to do is go ahead and collapse this parallel part, or the series part. And so I just simply add them together, 20 plus 10. That gives the equivalent resistance of this part to be 30 ohms. But that's in parallel with this one. And that will give us a 1 over RT to be 0.2. So we find the total resistance, that's going to be 5 ohms. Okay. So this whole section here is the equivalent of 1 5-ohm resistor. And then this is in series with that one. So to find the total resistance of the entire circuit, we get a total resistance of 20 ohms. For this larger circuit, we actually have 2 parallel components. These 2 are in parallel with each other. These 2 are in parallel with each other. But this segment and this segment are both in series with a 4 ohm resistor. So I will go ahead and find the total resistance here, find the total resistance here, and then simply add them together. And if you do, you should find the equivalent resistance of this entire circuit to be 16.75 ohms. So if we give that one a try, remember, parallel part for this one, parallel part for this one, and that's in series with the 4 ohm resistor. Thank you. On the next video, we'll actually figure out the currents and voltages for individual resistors in a combination circuit.